All right, folks, this is one of those Band-Aids we got to rip off. This is where, within a question, there's 1, 2, 3, 4, 5, 6, 7 problems to solve, and then we got to take it a step further, in this case, to make a chart out of the 7 problems that we solve. So let's get to it. According to a survey, about 33% of people ages 16 and older, in other words, the experiment's already been done. We know 33% of people asked who are 16 and older own an electronic reading device or e-reader. Could have been a phone because they have those, could be an iPad, could be an actual dedicated e-reader, different things like that. You decide to ask 6 randomly chosen people who are 16 and older whether they own an e-reader. I don't know if you're trying to check to see if the numbers are right or what. Number one, 6 wouldn't be enough to test the data to say 33% of people do, but you're just trying to see, hey, let's see if it falls in line with just 6 people. It could. Not you should be picking more, but you could. We're going to draw a histogram with a binomial distribution for my survey. So really what it's saying is, how many people should I expect out of the 6 to own an e-reader? Well, there is if there are independent trials, no matter how many there are. In this case, we have 6, and we're going to be asking 6 different people at random. Those are considered independent trials. So our N, remember we talked about N and R's. Our N is going to be 6 because we are conducting 6 independent trials. We're going to be asking 6 different people. And each trial has only 2 possible outcomes. In this case, they either own an e-reader or they don't. There's not a third option like they own it, but they lent it to their, no, they either own it or they don't, okay? And the probability of success is the same for each. In other words, if you ask them, there should be a 50-50 chance. It's either one or the other. They have equal amount of success to be able to say yes or no. Now, we're not taking into account that 33%. What we're doing is a yes or no answer has a 50% chance. He has 50% chance no. Just off strict probability, there's ways to calculate weights and things like that into potentially potentially getting more yeses than no's or no's than yeses. We're not talking about that. We're talking about the probability that they say yes or no is the same. The chance that they say yes or no is the same. In this case, it is. It's either they have a 50-50 chance that they are going to say yes or they're going to say no if you just ask somebody random. Now, if all of that is true, here in purple is the formula we're going to be using. And it's the formula we did use over on the left. So let's follow it. What this says is we are going to find the combination given the probability to the power of k of success. The probability of success to the power of k, and then the probability of failure to the n minus k. Now, k is the number of people we're asking. So really, when we have 6 people that we're asking and none of them say they own a reader, then we would have 0.33, or the survey says the chances of somebody owning an e-reader, success, 0.33 to the 0 power, that's our k, remember, and then we have to multiply it by the chance of failure. Well, that's 1 minus our 0.33 or 0.67 to the 6th. When we calculate that out, we get 0.09 or a 9% chance that 0 people we ask are going to say they do not own an e-reader. So our histogram would look something like that, just short of 0.1. When we go through and we ask the same 6 people, the chance of one of them having an e-reader is the chance of success to that one person who we would expect to say yes, times the chance of failure to the 5 people who say no. When we calculate that out, we get 0.267 or a 26.7% chance. That's going to be a lot higher up here. So if this is 25, 27, about right there. It's 27, 28, somewhere around in there. It's close. Now, the third one, and again, this is we've asked 6 people. We expect 2 to say no. They do not have, or sorry, yes, I do have an e-reader. So we take our chance of success, 33%, and we take it to the power of the people who say yes. So success goes with yeses, success. And, we take our no, the chance of the no, and we take it to the power of the number of people who would say no, and we get 0.329. So we expect 2 people to say yes, and that would be a 32.9% chance. So I'm going to go here, 35 is there, so a little over half. Okay. If I kept going, 6 people, 3 people to say yes. 6 people, I expect 4 people to say yes. And I'm just gonna have to do this. 6 people, 5 people to say yes. 6 people to say yes. The chances end up being the order you see on the screen now. And to graph those, I would simply go to, I would expect 3 people to say yeses here, and I would go up to 21.6, about right there. Yes, I'm estimating because 21.6 isn't made. If you use something along the lines like Excel, they would be exact. 0.08 is actually just shy of our first one, which would be right around in there. 0.016, that's going to be even shorter, about right there. And 0.001 would be so small it wouldn't even show up on our chart. So now we have calculated the chance of asking 6 people and nobody saying yes, 6 people, 1 person saying yes, 6 people, 2 people saying yes, 6 people, 3 people saying yes, 6 people, 4 people saying yes, asking 6 people and 5 people saying yes, and asking 6 people, and the chance 6 people will say yes, they own an e-reader. And that's by taking the chance that they do, according to the study, in this case, 33%, to the power of the people who say yes, and multiplying that times the chance somebody will say no, or 1 minus the chance somebody says yes, to the power of the amount of people who say no. And each one of those led to a specific number which we can chart to show the distribution of expectation of people, of the number of people out of 6 we would expect to say they own an e-reader.